Today we're going to be relating parallel and perpendicular lines, and hopefully you already jumped through these and noticed that when you see a bunch of parallel things going on, our conclusion will be parallel. So, not such a big deal. But over here it would be just the diagram, and what we do notice, and you can start marking it even as you go, you know that M is parallel to N, right? We also know that N is parallel to K, and what's your instinct say about M and K? Your instinct says. All right, so notice here, 1 and 2. Notice that angles 1 and 2 are formed by these lines, this M, this N, and the transversal. So I'm going to focus on those two right now. So I just need to write down that M is parallel to N. M is parallel to N. Now, many of you also put this up in the top there. And that's okay. If you did put both the given, all the given right here, then you would just scratch out step 3. Step 3 would not be something you would even need to include. So the first one is given. All right, so since I have parallel lines, why is it that I have congruent angle in the right direction? So we could call this the corresponding angles postulate, or you could say parallel lines cut by a transversal, then corresponding angles are congruent. Now, N is parallel to K, and that one's given. Why did I write it here? Because I'm going to use it now. All right, because of that, I have corresponding angles says that angle 2 has to be congruent to angle 3. And then why is it true that now angle 1 is congruent to angle 3? All right, so to get official on this step, we are going to say that it is the transitive property of congruence, officially. Transitive property of congruence. And now, if I look at my diagram at 1 and 3, notice that angle 3 is here, angle 1 is here, and effectively I'm just ignoring this. So now I have two lines cut by a transversal such that corresponding angles are congruent. So my conclusion here is that M is parallel to K because of the corresponding angles converse. Corresponding angles converse. Remember when we use the converse? Converse is when we are starting at something like congruence and going to parallel. We use just the postulate or the theorem when we have parallel and we're going to congruence. In this case, congruence. So it was asked earlier, why can't they just make a theorem? Well, they didn't do anything. You did. So what would we call this theorem? Let's call this parallel transitivity, or the transitive property of parallel lines. Now, books generally don't call it that, so you might need to summarize it in other ways, but I'm going to call it parallel transitivity. If two lines are parallel to the same line, then they are parallel to each other. If we had to summarize this, we would get if two lines are perpendicular to the same line, L, then they are parallel to each other. So we can't call this the transitive property because the actual function changes. So if two lines are perpendicular to the same line, then they are parallel to each other. Good, so now let's go ahead and prove that puppy. Remember that as we go on a proof, one thing you should always do is mark it up. If it hasn't been marked, the moment you write it down, go over to your handy-dandy diagram and start marking things congruent. Holy mushkama pe fundo meu. We are told that this right here are perpendicular, so therefore we can conclude something about that. And we know perpendicular here, so we can conclude something about that. And if we look at my diagram, since these are both right angles, that means they're congruent. And if they're congruent, corresponding angles are congruent. And if corresponding angles are congruent, lines are parallel. So as we look at this, officially this proof should probably have another step in there. But perpendicular goes to 90. There's no direct theorem. So this is actually definition of perpendicular lines, and then we're also saying the definition of right angles. If you only put one of them, that would be sufficient. In fact, the bestest one would probably be this one right here, the perpendicular one. Okay. Next, both of these, angle 1 and angle 2, are equal to 90. So what is true about angle 1 and angle 2? Good. So now this one is the definition of congruent. And if you simply say definition of congruence, that's fine in dandruff, but specifically congruent angles in this one. And lastly, we need to look at our diagram for angle 1 and 2. Angle 1 and 2, what's their relationship? What's the name of their relationship? And they are corresponding angles. So you can either say corresponding angles converse, or you could say corresponding angles are congruent, therefore parallel lines. You could summarize it, or you can say if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Word to your grandmother. So look at that. We get into class, we bust out two proofs. Holy high hurdles, Batman. Amazing. So as we consider this next one, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So looking at this diagram here, clearly we see two things. Number one, L and M are parallel. And number two, N and L are perpendicular. So my conclusion is N has to be perpendicular to M also. So that's my conclusion here. N is perpendicular to M. The given information is red, my conclusion here in blue. All right, now take a gander here at number 15. Discuss with your partner and complete each statement by putting in letters, the names of the lines, A, G, or T, in these spots. Go. Good.
So G is perpendicular to C.
G is perpendicular to T. All right, and so it feels like a transitive, but remember transitive means that the symbol has to stay the same. We go from parallel to perpendicular to perpendicular. Not from perpendicular to perpendicular to perpendicular. Or not from parallel to parallel to parallel. So transitive applies to the same symbol the entire time. And what about number 16? Explícame, por favor.
C is perpendicular to N, and N is parallel to P, so C is perpendicular to P.
Discuss